Geostationary and polar satellites. In the previous section, we saw that the time period of an Earth satellite is given by t equals 2 pi into Re plus h by v equals 2 pi into Re plus h whole raised to 3 by 2 by under root of g into me. Any satellite in circular orbit in Earth's equatorial plane such that its time period t is 24 hours, which is the time period of rotation of Earth around its axis, would appear to be stationary when viewed from the Earth. Such a satellite, which is stationary with respect to our Earth, is known as geostationary satellite. For such satellites, Re plus h equals t squared gme by 4 pi square, the whole raised to 1 by 3. In the above equation, when we consider t equals 24 hours, then h equals 35,800 kilometers, which is much larger than Re. Though it requires very powerful rockets to launch satellites at this height, geostationary satellites are launched due to their benefits in areas such as meteorology and remote sensing. Geostationary satellites are used to transmit communication signals which require a large array of antennas at different places on Earth in a cost-effective manner. Electromagnetic waves above a certain frequency are not reflected by the ionosphere. Radio waves in the 2 MHz to 10 MHz below the critical frequency are reflected by the ionosphere. In other words, the signals cannot reach beyond a certain range. Television and many other communication signals cannot be received beyond the line of sight. Geostationary satellites are used to overcome the above-mentioned barriers. These satellites can receive signals and beam them onto wide areas on the Earth. Government of India began launching its geostationary satellites, known as Indian National Satellite, INSAT system satellites, in 1983. While geostationary satellites orbit along the equatorial plane, polar satellites, also Earth satellites, orbit in the polar plane, in the direction of the north and south poles of the Earth. These satellites, with a time period of 100 minutes, orbit at low altitudes in the H approximately equal to 500 to 800 kilometer range. A polar satellite covers one strip of land in the longitudinal direction in one orbit. In the next orbit, it covers the adjacent longitudinal strip, and so on. Thus, it takes an entire day to cover the whole Earth. As polar satellites have low altitude, they give out high-resolution images. Polar satellites can give close-up images of the Earth. Polar satellites are particularly used to study polar and equatorial regions and are used in meteorology, remote sensing, and environmental studies.